In these problems, what we have is a couple of radical expressions multiplied together. And you probably know that if you have a couple of radical signs multiplied together with different values in them, you can go ahead and just put those all together, multiply them under one radical sign. So the square root of 2 times the square root of 7 is the same thing as the square root of 14. That is how I'm going to approach these problems. I'm going to multiply everything together first and consolidate all the variables, and then we'll see what we can do about simplifying by taking some square roots. So let's start here. I'm going to start with the number part. So I have a 2 and a 6 here. If I multiply those together, I get 12. I'm going to make my big radical sign here. And then the w part, I have 1w and then 2 more. So w times w squared is w to the third. And then with x to the sixth and x to the third, I multiply those together, adding the exponents, I get x to the ninth. Okay, so here's my big radical expression. What I want to do now is pull out whatever perfect squares I can, take square roots of things. So let me actually factor this into some perfect squares. 12 is 3 times 4, so I'm going to pull a 4 out, and that would leave a 3. And then a w to the third power, I'm going to pull out a w to the second power, leaving a w. And x to the ninth, I'm going to pull out an x to the eighth, which would just leave an x. Okay, so now I've got two factors here, and this one is a perfect square. So I'm going to go ahead and take the square root of all of this. The square root of 4 is 2. That goes on the outside of the radical symbol. Square root of w squared is w. Square root of x to the eighth is x to the fourth. And then what's left on the inside is my other factor, the 3wx. And that is as simple as that one can get. Let's try another like that. Again, I'm going to multiply everything together first, starting with the number 5 times 10 is 50. This is, of course, all under our radical sign. V squared times v to the third. We're adding exponents. That's v to the fifth. And x to the eighth times x to the fourth is x to the 12th. Okay, so there it is, all consolidated. Now let's see what we can do in terms of factoring out some perfect squares. 50 I know is 2 times 25, so that jumps out at me right away. I'm going to pull the 25 out of there. And that would leave, in our other factor, put some parentheses here, that would leave the 2. Now v to the fifth, I'm going to pull out a v to the fourth, leaving just a v, single v. And x to the 12th, well, that can all come along because any even power here is a perfect square. So all I'm left with there is 2v, and that's fine. Let's go ahead and take the square root of our perfect square here. The square root of 25 is 5. Square root of v to the fourth is v to the second. And the square root of x to the 12th is x to the sixth. That's all outside the radical sign. And inside we just left the 2v. So that is a little bit of work with dealing with products of radical expressions.